right, so what I get then is a final equation for the force of kinetic friction. So this is your kinetic friction force. Let me scroll up. And this is your coefficient of kinetic friction. This is your normal force. And unit-wise, force is a force, of course. So this is a Newton, and this is a Newton. And when you have a Newton is equal to something times a Newton, what's the something? Nothing. No thing. Oh, that's silly. But nothing. No unit. It's just a number. Now, let's talk about that number. We looked at our graph from yesterday, and we had a steep slope and a shallow slope for the two different interactions. So we had one that was a high slope, one that was a lower slope. This was the force applied, which we have learned is now the force of friction. And if you convert this to weight, so you had mass, if we convert those to weights, which would just be moving a decimal, we could have the gravitational force here, and that would be in newtons, and this would be in newtons, and we get these slopes. So the slope of this graph right here would be your coefficient of static friction, and the slope here would be the coefficient of kinetic friction. And as a rule, the coefficient of static friction is always greater than the coefficient of kinetic friction. It's always harder to get something going than to keep it going. Another important thing about the coefficient of friction, if we did enough experiments, you would learn, all of you got a number that was positive, okay, but you all got numbers that were less than 1, most of you. I think there might have been one table that had some problems with their numbers, but most people got like 0.005, 0.0065, 0.007. Okay, so your coefficient of friction is always going to be positive, but it will be less than 1. And then your coefficient is going to kind of determine a relative roughness or smoothness, depending on how you want to look at it. So like a 0.9 is rough compared to a 0.2. Does that make sense? A 0.9 would be a very high slope and a very rough surface. A 0.2, comparatively, would be a smoother surface, a lower slope. And you know, I love a graph, so this is a graph of force versus force. Now, in all of these cases, there was a theme that I was trying to get you to understand, and that was what? What was the theme? All of these bodies were in what? Equilibrium. And equilibrium goes with what? What does equilibrium go with? A zero acceleration, which then gave us what? It also goes with what? What was the other thing? The sum of the forces was 0. So this is Newton's first law. So the object at rest stays at rest, and object in motion stays in motion unless acted on by an unbalanced force. In all of our cases, we had balanced forces. The objects were in equilibrium. So that's what equilibrium looks like. It looks like an object not moving. It looks like an object moving at a constant rate.